It began suddenly, didn't it? Perhaps a coffee cup slipping from her hand, just once, then again the next morning. By the end of the month, she couldn't hold a pencil, and the word for pencil, coffee, even her own daughter's name, kept slipping away too. Can you imagine the terror, the frustration as your own body and mind betrays you in such insidious ways? Somewhere deep inside her brain, a single misfolded protein was multiplying like a runaway line of bad code, shutting down the intricate circuits that let us move, think, and feel. This protein is mutated huntington, and once it starts its destructive work, it never calls a truce. It's a silent saboteur, slowly but relentlessly hijacking brains, one neuron at a time. Most people first encounter the word Huntington's with a jolt, usually when a relative receives the devastating diagnosis. But here's the thing. The disease doesn't just suddenly appear. It actually starts years, sometimes even decades before a doctor ever signs the chart. Before I dive into how you should think about it, well, it has to be a bit technical, but please try to keep following. And if there's any doubt in what I'm saying, please comment down below, because I'd like to answer it, and I'm trying to keep it as simple as possible, but still keep it so we actually get the right terminology. And you can think of it like this. On chromosome 4, our HTT gene has a specific sequence, a series of CAG repeats. In Huntington's, there's a short stutter, an extra unwanted string of these CAG repeats. Almost like a broken copy-pasted command in your DNA. The more repeats there are, the longer the trail of glutamine bricks gets stuck to the Huntington's protein. When that tail extends past about 35 repeats, the protein snaps into a new sticky shape that clumps together inside neurons. These protein aggregates are particularly toxic to certain brain cells, especially the medium spiny neurons, or MSN. These reside in crucial areas called the striatum. Picture these MSNs as the brain's traffic light, controlling the flow of information for movement, thought, and emotions. When they begin to die off, these signals jams, thought stalls, and movements runs red. Because this damage starts deep beneath the brain's wrinkled outer layer, the cortex. Clinicians refer to the resulting cognitive decline as subcortical dementia. It's a slow-motion power outage that often leaves language islands intact, meaning that a person might still be able to articulate their distress in perfect sentences, while systematically erasing the ability to plan tomorrow's breakfast, or even remember what they had for breakfast. It's a cruel irony, isn't it? Let's zoom in on what this mutated protein actually does inside a cell. Imagine a healthy Huntington protein as the cell's meticulously quality control inspector. It's a busy little marvel, escorting vital cargo along microtubulent highways, helping the mitochondria, our cellular power plant, generate ATP, and standing guard against stress signals. It's essential for neurons' health and function. But if we swap in the mutated version and this once reliable inspector turns rogue, it barricades those cellular highways, sabotages the mitochondria, plunging the cell into energy crisis, and flips the stress switch to panic mode. The cell, in a desperate attempt to clean house, tries to vacuum up these toxic bundles through a process called autophagy. But the mutated proteins, cunning as it is, blocks the disposal shuts. Calcium leaks, ATP dwindles to dangerous low levels, and synapses, The communication junctions between neurons fall silent. This cellular chaos eventually manifests as the first clinical hints, often subtle enough to be easily dismissed: a tiny fidget, an extra blink, a shrug that wasn't quite on purpose. Relatives might even joke about restless legs or clumsiness until those jokes turn sideways. Job plans become common, punchlines are slurred or forgotten, and a temper that explodes over missing car keys replaces a once calm demeanor. Meanwhile, deep within the brain, the caudate nucleus and putamen, key parts of the stratum, begins to shrink visibly on MRI scans, the ventricle ballooning like, well, an empty room in an abandoned house. A stark visual of the ongoing devastation. When we talk about dementia, most people think of Alzheimer's, which is a cortical dementia that strips away recent memories and vocabulary, often leaving someone lost in their own past. But subcortical dementia, like the one in huntingtons, are different. They don't necessarily erase what you remember, but they steal the tools you need to use what you still possess. It's like having a library full of books, but no longer knowing how to read or even finding the one you want. Executive dysfunction, for instance, shows up early and hits hard. Planning, organizing, multitasking, problem solving, these become Herculean tasks. Balancing a checkbook feels like running a marathon in quicksand. Every decision, no matter how small, becomes a long distance call due to the psychomotor slowing. Thoughts arrive late and often garbled. Memory itself isn't completely gone, but recall becomes a frustrating guessing game. Give the person three choices and they might pick the right answer, but left alone, their mind draws a blank. What's particularly potent is that language and practice, the ability to perform skilled movement, often survives longer. So patients can describe their misery in perfectly formed sentences, even as they can no longer act upon them. It's a profound disconnect. And then there is the emotional toll. Apathy frequently masquerades as depression, irritability, as a mere personality flaws, until families are left wondering which quirks truly belong to the disease and which to the person they once knew and loved. It's heartbreaking to witness. Huntington's disease carries a unique and heavy genetic burden. It's autosomal dominant. And by now you are asking, what the hell does that mean? Well, it means that you only need one faulty copy of the HTT gene from either parent to inherit the disease. This translates to a terrifying 50-50 lottery for each child. Imagine the agonizing decision making, the dread, the profound impact on family planning. It's a choice no one should ever have to make. Currently, about 41,000 Americans are manifesting symptoms, but here's the kicker. Another 250,000 carries the gene and are simply waiting, living with that silent knowledge. Worldwide, the prevalence hovers around 10 per 100,000 amongst populations of European ancestry. It is thought to be partly due to the average CAG repeat length and the different HTT genes haplotype in various populations. It's much lower in East Asia and Sub-Saharan Africa. And the age of onset typically clusters between 30 and 50 years old. However, there's a brutal juvenile form, defined as onset before the age of 20, which accounts for around 5 to 10% of cases. This form progresses twice as fast and often inherits from the father. Twists link to further CAG expansion during spermatogenesis. It's a heartbreaking race against time for these young individuals. After a motor diagnosis, life expectancy average 15 to 20 years, but that runway can be significantly shortened by complications like pneumonia, falls, or choking, which are all too common as the disease progresses and impacts motor control and swallowing. For medical professionals, this disease has a specific identification. ICD-10 coders label the underlying disease G10. When dementia declares itself, they add F02.2 and tag the severity, mild, moderate, or severe, based on how many tasks needs a caregiver's hand. This coding isn't just for billing. It's crucial for tracking disease progression, ensuring appropriate care, and informing research. Let's zoom in anonymously, of course, on one household. Dad, a vibrant man of 42, received his positive test result after his own mother succumbed to complications of rigidity, an euphemism for the final devastating stage of Huntington's disease. Within months, his steady gait begins to resemble a pinball bouncing off hallway walls, a disturbing involuntary dance. His teenage daughter, forced to grow up too fast, learned to cook pasta one-handed, her other hand instinctively steering his wrist away from the stove's flame. She developed a sixth sense for his unpredictable movements. Mom, ever the pragmatist, keep a meticulously updated list of dangerous utensils taped inside a cabinet. Knives, corkscrews, even a potato peeler that one agonizing afternoon triggered a full-blown meltdown when his hand refused to cooperate. Dinner, once a lively affair, became a tightrope walk. Dad still cracked jokes, but the punchline arrived 3 beats too late, landing in the awkward, heavy hush that would settle over the table. At night, in moments of painful clarity, he apologized for his broken brain wires, then asked with a child's heartbreaking innocence if tomorrow they could fix the wire with pliers. 6 years in, he can only swallow thickened liquids. A slow, arduous process. His daughter, now an adult, signs consent forms for a feeding tube trial. Her hand steady, but her heart is heavy. Through every tremor, every forgotten word, every outburst, the family clings to one brutal truth. Every single symptoms track back to a protein they cannot see, a polypeptide snowflake that refuses to melt, slowly consuming the man they once loved. So what can we actually do right now? Honestly, our current medication is mostly just whispers, rather than a roar. Drugs like tetrabenzaine and detutrabenzaine can help tame chorea, those involuntary jerky movements, by depleting dopamine. But it's a tricky balance. They often deepen depression, trading one burden for just another. Antipsychotics might blunt irritability, but they can stiffen limbs, creating a different kind of movement deficit. SSRIs can quiet obsessive rituals and anxiety, yet a profound apathy often remains, a shadow that no pill seems to lift. The truth is, nothing today halts the underlying cascade of neurodegeneration. At best, these drugs buy a little dignity, offering smaller, shorter doses of reliefs. That's why supportive therapy are so vital. Physical therapy helps postpone contractures, keeping the body as mobile as possible. Speech therapy addresses the communication and swallowing difficulties, reducing the risk of aspiration. High-calorie shakes fight the relentless weight loss that often accompanies the disease. It's a multidisciplinary battle fought on many fronts. Meanwhile, researchers are chasing truly disease-modifying therapies like gene silencing. They're developing antisense oligonucleotides, oh, that's a damn difficult word, so let's just call it ASOs, that tell cells to slice the HTT messenger RNA, effectively preventing the production of the mutated protein. CRISPR approaches aim to precisely excite the CAG expansion from the DNA itself, a bold gene editing strategy, and small molecules are being explored designed to coax the mutated protein into a friendlier, less toxic shape. Early trials like Precision HD have shown some oligons can lower huntington levels in spinal fluids. But here's the rub. The brain is a fortified castle protected by a formidable blood-brain barrier. Getting these sophisticated drugs across its moat and into the target neurons remains the final monumental boss fight. Despite the immense challenges, hope is not just a whispered rumor. It's a growing crutch. In 2023, the selected HD trials from Wave Life Science reported partial dose-dependent lowering of mutated huntingtons without serious adverse events. This was a milestone, a moment once thought impossible. Imagine actually reducing the toxic protein. Wave Life Science is pioneering the allele-selective approach with the VWE003, which specifically targets only the expanding copy of the A gene, cleverly sparing the healthy ones. Why is that important? Because the healthy Huntington's protein actually has a crucial job to do in the cell. Then there is Unicure's AMT130, which use a single-shot AAV vector to deliver microRNA designed to silence the Huntington's genes. Roche and Novartis are hitting their bets with monthly intrathecal infusions delivering therapy directly into the spinal fluid. Pfizer, meanwhile, is scouting for small molecular chaperones that could refold that troublesome polyglucosamine tail into something less harmful. Each strategy carries inherent risks, potentially immune reaction, surgical complications from direct brain or spinal delivery, or simply the agonizing ticking clock inside every symptomatic brain where neurons continue to die. Yet for the first time in a long time, families are speaking the word cure without flinching. Yes, the timeline still stretches into the 2030s, but the conversation has shifted from managing declines to actively seeking reversal. And there's more. Pre-symptomatic genes carriers, those living with the knowledge of their genetic fate, are joining observational studies. These involve annual blood draws, lumbar punctures, and brain scans, all to meticulously map the exact moment neurons tip from coping to collapsing. This invaluable data will tell further trials precisely when to strike, optimizing the timing for potential interventions and bringing us closer to a future where Huntington's is not a death sentence, but a treatable condition. If these stories resonate, If it feels close to home, please know you're not alone. Genetic testing paired with compassionate counseling can replace dread with data, offering clarity and options. Organizations like Huntington's Disease Society of America are beacons of hope. They run vital hotlines, foster supportive communities through local chapters and support groups, and, well, funnel coffee money donations into lab-grade pipettes fuel the very research that's bringing us closer to a cure. So don't let myth persist. Share this with one person who still thinks Huntington's is just shaking. Eric corrected myth, move us a neuron closer to a cure. Hit subscribe if you want more, well, scientific nursing knowledge stripped of, well, as much jargon as I can, and drop your questions below. Yes, I read every thread. Let's keep this conversation going. Because a mutated Huntington, it's a saboteur that slips past birth, lies hidden for decades, then ruthlessly rewires the very circuitry that makes us who we are. And if you want more dementia related videos, then check out this video right here where I talk much more about dementia. It is an entire playlist with all the dementia knowledge you need. So check it out, and I'll be seeing you in all these videos. They are small in its own, but a great binge watching worth episode if you want to know more about dementia.